All right. So thank you guys so much for coming. We're really excited to be here with you guys. We know that unfortunately you weren't able to come to Explora and have your actual physical family science night, but we're going to try out tonight a virtual family science night. So hopefully all of your family is there with you, and we'll be doing some fun activities today that you can do at home with some materials that you have around the house. Before we get started, I want to thank APS Title I. So those are the folks that bring the Family Science Nights, or bring you to the Family Science Nights at Explora, and that are bringing us to your homes tonight to do this event. So my name is Kevin Dilley. I'm from Explora Science Museum, and we're going to have a lot of fun today. We're going to do some hands-on activities. Hopefully it'll be a little interactive. All right. So we're going to do some experiments today, and if you want to do them at home, I encourage you to do them. Some of them, you definitely need some parent supervision or adult supervision to do them. But any of the things that you do, please share them with us. We would love to hear and see maybe videos or pictures of you doing these experiments or any other experiments. And so you can reach out to us through our social media things. So through Facebook, we're at Explora Science Center. Our Twitter handle is at Explora_NM. And if you use the hashtag #HowWeExplora, then we can all see that, okay? So any of the things that you're recreating at home tonight or in the weeks that follow, please use the hashtag #HowWeExplora, all right? So we're going to jump right into it. We're going to get into our first activity, and this one is one that you don't really need any special materials. All you need is a wall, okay? And this activity, your challenge is you're just going to try and stand up and stay standing. Sounds very simple, right? We'll see if we can do it. So if you want to, you can join me in doing this. You just need a wall that you're going to stand next to. So feel free to get up. Everybody in the family can do this at once right next to each other. What you're going to do is you're going to stand next to the wall. You're going to put your foot, one of your feet, right against the bottom of the wall, and put your shoulder against the wall as well, okay? So you're going to keep your shoulder, and you're going to keep your foot against the wall. And your challenge, like I said, is just to stay standing. But what you have to do is lift up your other foot, not the one that's touching the wall, but the other one. Just lift it up and stay standing, okay? And see if you can do that. Remember, try and keep your other foot against the wall, okay? See if you can lift it up and stay there. I'll give it another try. See if you can do it. Are you able to do it? Is anybody able to do it? No? All right. Well, let's find out what you notice happening. What's going on with that whenever we are trying to stay standing? And so we're going to figure out the science behind that. And so with that, we have to think about the center of mass. And so basically what that means is, where is all of your weight? Where's the middle of where all your weight is? Okay. So if you're just standing up normally, just like this, then you're standing on both feet. And I want you to do it away from a wall and try and stand on one foot and stay balancing up. Notice what happens. So what happens if you lift your foot up and you're able to stand and balance there? What are some things that you notice? If you notice anything in particular, go and write it in the chat. But one thing that you might notice, what's the first thing that you have to do to be able to stay standing and be balanced? So first thing that I notice is if I'm lifting my foot up, hold on, Augie. If I'm lifting up my foot, the first thing I have to do is I have to kind of shift my weight over. Notice that I'm going over to the side a little bit, and then I lift my foot up, and that allows me to balance. So our center of mass in us, it's basically right here, and we have to get that over what it is that we're balancing. So we have to get it over our foot to be able to stay balancing and not fall over, okay? So that's one thing that you can do, and anybody in the family can do that. Hopefully you'll have fun doing that. I've got one more, and this one requires, come on in if you want. This one requires either the wall that you just used, or you can use a door jamb, okay? So we're gonna use the door jamb here. And if you do it against the wall, you're just gonna stand against the wall and use one arm. But with this one, in the door jamb, you are going to have your arms pressed out against the sides of the doorway. So you're going to keep your elbows straight. Don't bend your elbows. Keep them nice and straight. Put your wrists and the back of your hands against the walls, against the door frame, and push. Push nice and hard, keeping your elbows straight. You'll start to feel it in your shoulders. And so we're going to do push nice and hard, nice and hard. We're going to do kind of a slow count to 20. And so I'll get started. 1, 2, 3, 4. And as we're doing this, keep pushing, keep pushing. You'll kind of feel it in your shoulders. 7, 8, 9, 10. After we're done with this, what you're going to do is you're going to stand forward. You're going to put your arms down next to your sides and relax them and see what happens to them, okay? 15, 16, 17, 18, 19. Keep pushing. 20, and then step forward. Put your arms to your side. Just relax them and feel what happens to your arms. What do you notice happening to your arms? Did anybody feel that? Did you see what happened to mine? I wasn't pulling them up. I was just relaxing them, and they were just naturally going up. So what's happening with that? What's the science behind this? Can you go forward just a little bit? What's the science behind this, right? So when we're pushing our arms up like that, we're engaging our muscles on the outside of our arms on both sides. We're engaging those muscles. They're getting nice and tight, and they're kind of staying that way. We're pushing on it for a long time. They're staying nice and tight, and when we come away from it, that tightness stays there for a while. It takes a while for them to relax. And so they want to tighten up, and so that causes our arms to lift up involuntarily. So it does it on its own. We don't try and do that. It does it on its own. All right. So those are some fun activities that you can do. You don't need any special materials. You just need a wall or a door frame to do those. So hopefully you can have fun doing that. It can be something that you can show your friends, show your family, and have a lot of fun with that. All right, we're going to move on to our next experiment. And for this one, you're going to need a few supplies. Okay, so you're going to need 2 pieces of paper. I've got some blue paper here, but it doesn't matter what kind. It can be any type of paper. If you don't have some scratch paper around, your parents are probably getting junk mail right now. And just save a piece of that junk mail and use one of those pieces of paper. You're going to need some scissors, and you're going to need some tape. And it doesn't matter what kind of tape. I just have some bright yellow paper. It's nice and easy for you guys to see it. So you're going to take 2 pieces of paper, just stack them right on top of each other. And it can be newspaper. It can be any type. And we're going to cut it into 3 strips. So we're going to do 3 strips about the same size. So I'm going to cut 1 strip here all the way down. So we have a nice long strip of paper. And we're going to cut 1 more time here. So now we have another nice long strip of paper. And so this is going to give us 6 pieces of paper. Okay, 6 strips of paper. So that's great. And now what we're going to do is you are going to take one of those pieces of paper, and you're going to take it and you're going to make a little loop with it. So just a nice simple loop like this. And you're going to take a piece of tape and that closed. Okay, so just like that. Okay, so we have a nice loop like that. And what we're going to do is we're going to cut along the whole length of this loop. And if I do that, what do you think we're going to get? Go ahead and write that in the chat. If we cut along the whole length of this loop, of this strip of paper, what are we going to get? Okay, let's see. I'm not seeing anything yet in the chat, but think about what we might get and go and write it in the chat. And while we're doing that, I'm going to start my cut. So I'm going to start cutting here, just kind of down the length of the whole thing, kind of go around the loop here. See what we get. And let's see, what did we get? Ooh. Okay. So that wasn't super surprising, right? So there's probably a few of you that thought we would get to, and in fact we did. Okay, and that's great. Now we're going to do the next level of this. Okay, so instead of just doing the loop and taping it, we're going to take another piece of paper, and I'm going to mark on this so that you can see what's going on here. I'm going to mark a black kind of dot on one side of this, on each end on one side. so that you can see that on this side, on the ends, we have black dots. On the other side, it doesn't, okay? So what we're gonna do, when we loop it together this time, instead of putting them together like this with the 2 black dots on the same side, you're gonna twist one of those so that we get the one of the sides that doesn't have the black dot and one that does have the black dot on it. And we're gonna tape those together, okay? So now we've got this kind of half twist on our piece of paper. And we're gonna tape this together. And the same question. What is gonna happen if we cut along the length of this loop? What are we gonna get? Remember what happened in the first one, right? We got two separate loops, 2 circles. What's gonna happen if we cut through this one? And so go ahead and write your answer or your guess, your prediction in the chat and see what we get, okay? So I'm seeing some different things in there, and we're gonna give it a try now, okay? And you can do this at home as well, give it a try. So we're gonna cut through this, the whole length of it. Remember that first one, it gave us 2 loops that were 2 circles. This one, when we do it, it gives us 1 loop that's twisted, a longer loop. Was that expected or was it a little unexpected, huh? That was a little surprising, huh? So we've got now a longer single loop. All right, so that was level 2. Now let's do level 3, okay? So let's get another piece of paper. Let's draw, I'm gonna draw a mark on here so we can see which side is which. So one side has the black mark on it, right? The other side doesn't. Now we're gonna do a full twist, not just a half twist. So we're gonna twist it. So the first one, we did it like this, where it was just the 2 dots lined up. The second one, we twisted it so that it was the opposite sides. Now we're gonna twist another time so that we get the 2 black sides to line up again, but there's a full twist in our paper, okay? So let's tape that back together. And now, same question as before. If we cut down the length of this loop, what are we going to get? Go and write it in the chat. I'm going to give you a few seconds to really think about what you might get with this one. The first one, we got 2 circles. Second one, we got a longer loop that was twisted. And now with this third one, what do you think is going to happen when we do this full twist on the paper? What are we going to get when we cut through it? All right, let's give it a try now, okay? Here we go. Cutting through the paper all the way along the length of the strip of paper, just down the center of it. This one's a little bit trickier because of all the twists in it. But just stay in the middle, get all the way down. And we see that we got 2 loops that are linked together like that. See that? We've got 2 loops that are linked together. We've got 3 different things that happened whenever we cut these papers down the center, just by twisting it, okay? So that was level 3. There's one more level, okay? Level 4, this one we're gonna need 2 strips of paper, okay? So we'll get 2 strips of paper. We're gonna tape them together like we did the first one, where we just have the regular single loop on it, okay? Each one you're gonna do that to it. That we have 2 loops that both look like this, okay? Now, this is the tricky part. Instead of, we're gonna tape them together, but we're not gonna tape them together like this, where it looks like a number 8 or an infinity sign or anything like that. We're gonna have them like this, and one of them is gonna be twisted. So they're kind of, one the tube is facing up, and the other one the tube is facing forward. And then we're gonna tape these together, okay? So we're gonna tape them in all the places that it touches. We'll do one one piece of tape here that holds that together. Another piece of tape on the other side of that. Okay, so on this other side here, we'll tape this together. Okay, so those two are taped on each side. And then this one we're going to tape on these sides too. So we'll put one here. And one more piece on the other side, on this side. See how this part isn't taped together yet? We're going to tape that together. So now we have these two pieces of paper that are taped together. And they're kind of, one is going forward, the other one's going up. And now, same question. What if we cut along the length of each loop? What are we going to get? Okay, so I'm going to cut along the length of this loop all the way across, all the way around, and the same with this one, all the way around.
How do I get
what
rid of that?
Get with that one? What are we going to get when we do that? So go ahead and write your guesses, your predictions in the chat, and we'll see what we have created. So the first time, let's just review. The first time we had a single loop, and we got two loops when we did it. The second time, we put a half twist, and we got a longer loop whenever we cut that down the center. And the third one, we had a full twist. When we cut that, we had two links, two loops that were linked together. Let's cut this one and see what happens with this. So we'll cut along the length of each one of these circles. So I'm going to cut here along this circle. And so after we get this one done, we see that we have kind of, what does it look like? Kind of like handcuffs almost, right? And then let's cut down the length of this other piece of paper, and let's see what shape we get. And we see that we in fact get, from those two loops, we get a square. So I've got my little frame here that we can see that we did our experiment, and we were able to get our loops to create a square. All right, so feel free to do any of these at home. If you want to, you can even do more experiments, try out different things. What if instead of two loops, what if you put three loops together? Does it still give you a square? Does it give you something else? I don't know. What if you try one piece of paper and twist it 3 times? How long of a loop can you make? So try all sorts of different things. This is just a starting point for you to experiment and try out lots of different things with just paper and tape and scissors. Okay, this is what scientists and engineers do, is we investigate, we experiment. And I encourage you guys to investigate and experiment at home. Again, share your results with us. You can show us your frame if you want, or any of the other loops that you made. Go and share it with us at our social media sites. We'd really appreciate that. All right. Let's go on to the next activity, okay? For this one, you just need 2 books, okay? It can be any 2 books. It's up to you. I brought with me 2 of my favorite books. I have here Charlie and the Chocolate Factory from Roald Dahl, and the sequel to that, Charlie and the Great Glass Elevator, also by Roald Dahl. And so these ones, you'll notice, they're the same size, right? They're about the same thickness as well, but it doesn't have to be. It can be any 2 books. It could be really thin, it could be really thick, and we'll see, or you can see if that makes any difference on how the books act in this. So what we're going to do is we are going to test out to see if these 2 books can be separated. So if I just set them on top of each other like this is my son, Augie. Maybe you can help me, Augie, okay? So I want you to hold this book. I'll hold this one. Okay, and let's see if we can separate them, okay? So you ready to pull? All right, and that was pretty easy, right? That was pretty easy. All right, so the next thing we're gonna do is we're gonna open these up about halfway, each of them up about halfway like that, and we're gonna put one inside of the other. Okay, so it's gonna look something like that. And now, same thing, right? You ready to pull? All right, and still not that hard, okay? Now, The next thing I want you to do is we're going to try and intersperse, so put these two books together with the pages, kind of like you're shuffling a deck of cards. So we're going to kind of flip through it and put some of the pages in there and have them overlap, so we get a bunch of different pages like that. And so now I want to ask you guys in the chat, how easy do you think this one will be to pull apart? So do you think this is going to be super easy? You're still going to be able to do it, but a little bit harder, or do you think you're not going to be able to pull it apart? Okay, so think about that. Think about what might happen with this, and Augie and I are going to demonstrate. So you're going to hold that side, Augie. I'm going to hold this side, and we'll try and pull them apart. So we can't get them apart. Okay, that's enough. That's enough. All right. So we see that just putting it that many pages together, we were unable to get it to be pulled apart. So one way that we can open it up is, what if we tip it up like this, and then we see it's super easy to separate them. But just pulling straight apart, we weren't able to do that. So let's think about the science behind this. So why is this happening? And so there's something in this world called friction. And friction is something that you guys might have heard about. It's something you experience every day. Friction is basically this force that things in the world, when they're touching each other, rubbing against each other, it acts against them being able to move. Okay, so if you rub your hands together, like this, go ahead and do that. You're feeling the effects of friction. What do you notice about your hands when you're doing that? Anything that you notice? Hot. It's getting hot. Yeah, so it's getting hot. And so that's friction working. So the same thing. All right, we could snap at that right now. That's the same thing with this. When you have more surface area, if there's more stuff touching each other, it means that there's more friction. So when I just had when I just had it in half like this, there's not a lot that's touching each other. Those pages are touching, but it's easy to come apart. But when we have more and more surfaces touching each other, it means that there's more and more friction. So each one of these pages is trying to resist being pulled apart just a little bit, but it adds up because there are so many different pages there that when you do this, then you're unable to pull it apart. It's just really hard to get them to come apart, okay? Okay, and so at home, you can try this with any book. Try it with different size books, different books with different pages. Maybe some books have kind of different type of paper on them. Try those, see if that makes a difference. It doesn't matter if it's a hardback or a softback book. You can try those different things. And then, of course, after you've done the experiment or before you've done the experiment, don't forget to read the books, okay? So I think I might read this book later today, Charlie and the Chocolate Factory. So you guys make sure you find a good book to read as well. And you can do that before or after or even during some of these experiments that you're trying out, okay? So we're gonna do one last experiment. And this is one that you definitely need some adult supervision with, because we are going to be using fire. That's right. We're going to be using fire. And so the things that you need for this experiment are some candles. I happen to have some birthday candles here. It can be any candles that you want. You need a jar. I just have a mason jar. It can be a cup as well. You can have a second cup. Some baking soda. I've got some baking soda and some vinegar. Okay, so these are the different things that you need for this experiment. And what we're going to be doing is we are going to be making an invisible fire extinguisher. Okay, so we are going to be putting the fire out with science. Okay, so like I said, I have some birthday candles. And I want it to stand up. I don't happen to have any birthday cakes available right now. So if you happen to have a birthday candle or a candle that doesn't just stand up on its own, you can just get a cup or a jar, put some sand in it, or you can use some dry beans or dry rice, something like that, and you can just stick it in there, okay? So one little tip, if you are using the sand, make sure and wash off your birthday candle afterwards, because you don't want to have sandy birthday candle put into your actual cake later. But we are going to make an invisible fire extinguisher using vinegar and baking soda. And so here's how we're going to do it, okay? So in our jar, in our large jar, we are going to mix some vinegar and baking soda. So I'm just going to take a spoonful of baking soda and we'll put it into the jar like that. We're going to take about the same amount of vinegar and put it in there. And one other thing I forgot to mention, you need something to light your candle with. Okay, so either a lighter or matches or something like that. So I'm going to light my candle. Oops, let's get that going. All right, I got my candle lit. So my candle's going. And here's my cup. And just to prove I don't have anything in the cup, I'm going to try and pour it onto my flame and nothing's happening, right? It's not putting it out. I don't have any of my invisible fire extinguisher yet into here. But we're going to make it. So in our jar, we've got baking soda. I'm going to pour a little bit of vinegar. And what do you guys notice happening? What do you notice? Ooh, there it goes. We're creating lots of bubbles, right? And those bubbles are creating our invisible fire extinguisher. So I'm going to pour not any of the liquid, but my invisible fire extinguisher stuff here into my cup. And then I'm going to use this cup to put out my flame. There we go. So we created our invisible fire extinguisher using just vinegar and baking soda. So let's think about the science behind this, right? So let's figure out how this was working. So first of all, let's think about fire. What does fire need to stay lit, right?
Fire.
It needs,
oh wait, water, sorry.
So it needs some sort of fuel. So it's got the wax here, and also there's something called oxygen that's around us, and it needs oxygen. We need oxygen to breathe. Flames also need oxygen to be able to stay lit. And so it uses oxygen to stay lit. So it needs the fuel of the candle wax and also the oxygen to have the flame stay lit. Now, in our jar, what did we add? We added baking soda and vinegar. And so let's think about our states of matter, okay? So you've probably learned about these in school, and if not, this is a good review. So there are basically three main types of matter. There's solids, liquids, and gases. So let's think about what we added in here into our jar. The first thing we added was baking soda. What is baking soda? Is that a solid, a liquid, or a gas? Go and put it into the chat so we can see if you guys know your solids, liquids, and gases. So, all right. So that was a solid, right? I'm seeing a lot of people say solid. That's great. So that's a solid. What about the vinegar? When we put the vinegar in, what is that? Is that a solid, liquid, or gas? Go ahead and put that in the chat. All right, I'm seeing a lot of people say liquids. Great, yeah, it's a liquid. Just like water is a liquid, vinegar is a liquid, right? You see it sloshing around in there. Now, when we put those things together, what happened? Do you guys remember what happened when we added the vinegar and baking soda together?
It made bubbles.
It made bubbles. Yeah, go and put that in there. So it made bubbles. And now here's the interesting question. What is inside of bubbles? Is that a solid, a liquid, or a gas?
Gas.
I'm seeing people say gas in the chat. That's great. Yeah, so there's a gas inside the bubble. So gases, it's not like gasoline, like what you put in your car, because that's the liquid. But a gas is like the air around us. So that's a state of matter. And there's lots of different things that are in the air around us. There are different gases, like oxygen. Remember we were talking about oxygen that we need to breathe and also that the flame needs to breathe? So oxygen is a gas. And in here, it was creating a gas in those bubbles. And the gas that was in those bubbles is called carbon dioxide. You might have heard of that before because we breathe in oxygen and we breathe out carbon dioxide. And carbon dioxide is also what's made when you combine vinegar and baking soda. So we created a bunch of carbon dioxide in our jar here. And so you couldn't see it necessarily, but all of the air that was in here that contained all this other stuff inside the jar got pushed out. And the only thing that was inside here was carbon dioxide. And so carbon dioxide is actually a little bit heavier, a little denser than the all of the rest of the air around us. So it kind of sits in there and allowed me to be able to pour it from this jar into this cup. So then I had carbon dioxide in here, and I could pour the carbon dioxide onto the flame and smother it. So it took away all of the oxygen and just had carbon dioxide there to put out our flame. So that is how we can create our very own homemade invisible fire extinguisher using vinegar and baking soda to put out your flames. So I think that the easiest way to blow out my birthday candles is to blow on it. But if you want to do a scientific way, you could do your vinegar and baking soda to put out your birthday candles. Make sure you don't pour any of the vinegar onto your cake, because I don't think that'd make it taste very good. But that's one way that you can put out a flame using vinegar and baking soda. All right. So those are our 4 different science activities that we have done tonight. And hopefully you guys can do those at home. If you did them along with me, I hope you had a lot of fun. If you want to do them later, very simple materials that you can find around your home to do those. Again, I want to thank APS Title I for helping to put on this virtual family science night. Hopefully once people are able to leave their homes and Explora is open again, you guys will come visit us at Explora. I had a great time with you guys tonight. Hopefully you guys did too. Share any of the experiments that you do at home with us. Use the hashtag #HowWeExplora. And I hope you guys have a great evening. We hope to see you real soon. So everybody stay safe, and we'll see you guys later.